I am going to discuss center of mass. Here center of mass, what is center of mass, how it is useful while solving the numericals in work power energy. Let us see. Center of mass can be defined the point at which the entire mass of the body is supposed to be concentrated is called center of mass. Center of mass is a point at which entire mass of the body is supposed to be concentrated. What does that mean? If you take a ring, just make it to rotate the ring, it will be rotate about a particular point, that is the center of, about the center of mass it will rotate. Just rotate the pen, example. The pen is rotating about a particular point, that is nothing but center of mass. Here, let us see in general examples. If you see, when a cycle is moving, a cycle wheel is rotating, you can find out about the axle only entire wheel rotates, gets rotated, is it? The about which point the entire body is rotating, that is nothing but center of mass. We can find out, we can see the center of mass there. If the body is rotating, with reference to the center of mass it will be rotate, and if you throw a shuttle bat in a parabolic manner, the shuttle bat will be move in a parabolic. During its parabolic path, the entire shuttle bat will be rotate, but center of mass of the shuttle bat, we can notice that it move in a parabolic manner. One more thing, center of mass conditions and expressions, let us see what exactly. So expression for center of mass. Let us take a body, here another body, let us take point A, it is B, it is C. These two bodies of mass M and capital M separated some distance. A is, small m is at R distance, R1 distance, capital M is at R2 distance. So the point, if you hold at A, it will not be balanced. At B also it won't be balanced. At C means it will be get balanced, because the capital M and small m, both the masses center of mass is located closer to the heavier mass. So the distance is more R1, M1, distance is less R2, mass is more M2. The expression we can write as M1 R1 is equal to M2 R2. It is very important concept for the entire center of mass. Let us see that how to solve the numericals and what is the expression for the center of mass. Let us derive by using the original expression. Let us take a coordinate system, a body of mass M1, here body of mass M2. The center of mass will be 1 dimension, 2 dimension and 3 dimension. One body is there, center of mass will be there in the body. Two bodies are there, center of mass of the two bodies will be there in between them. That is called two body system. And three body system, n body system. Like 1 dimension, on the x axis assume that there is a rod. There is a rod assume. For that rod, two spheres are fixed along the x axis assume. Your rod, whatever you are considering, that is massless assume. Here we assume that it is an x axis. Mass is M1, here mass is M2, and position from the origin is x1, from here to here x2. It is R1, this is R2. Now it is XCM. Position of the center of mass. I am assuming the center of mass is here in between them. It is not exactly midpoint, because these two are different masses. Here, so we are assuming M1 at x1 distance, M2 at x2 distance. Now, M1 R1 must be equal to M2 R2. Fine. Here, M1 is mass of the first one, M2 is the mass of the second one. M1 R1 is how much? XCM minus X1. M2 is M2 only. R2 is how much? X2 minus XCM, because R1 xcm minus x1 r2 x2 minus xcm. Fine. Here m1 xcm minus m1 x1 m2 x2 minus m2 xcm. Here m1 xcm plus m2 xcm is equal to m1 x1 plus m2 x2. We can take xcm common, m1 plus m2 is equal to m1 x1 plus m2 x2. Now expression for center of mass xcm is m1 x1 plus m2 x2 by m1 plus m2. Let m1 plus m2 be, it is the expression for center of mass for one dimension system. The two particles are taken in the system, two bodies are taken in the system. So now if it is n particles are there, that time xcm can be written as xcm is equal to m1 x1 plus m2 x2 plus and so on by m1 plus m2 plus so on. Here xcm is equal to sigma mi xi by sigma mi. I is equal to 1 to n. I is equal to 1 to n. In such a manner, similarly we can write ycm and zcm also. Ycm means mi xi by mi I is equal to 1 to n. Zcm also similar way we can write off. Xcm is equal to, we got as m1 x1 plus m2 x2 by m1 plus m2. I will take m1 plus m2 as m. That time you can write as xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Here m1 plus m2 में capital M. So m xcm is equal to m1 x1 plus m2 x2. Now it is a position of center of mass. Now velocity of the center of mass, velocity of cm, center of mass. Differentiate d by dt of m xcm is equal to d by dt of m1 x1 plus d by dt of m2 x2. Here m into dxcm by dt is equal to m1 dx1 by dt plus m2 dx2 by dt. M into acm equal to m1 vcm is equal to m1 v1 plus m2 v2. In such a manner, vcm will be m1 v1 plus m2 v2 by m1 plus m2. Similarly, acceleration of the center of mass. Acceleration of the center of mass can be obtained in such a way. Already we got as m vcm is equal to m1 v1 plus m2 v2 by m1 plus m2. We can take as capital M vcm equal to m1 v1 plus m2 v2. Differentiate both sides with respect to time. The time m into d vcm by dt is equal to m1 into d v1 by dt plus m2 into d v2 by dt. Here we come to know that m differentiation of the velocity, time rate of differentiation of velocity is nothing but acceleration. It is acm is equal to m1 a1 plus m2 a2. Here acm is equal to m1 a1 plus m2 a2 by m1 plus m2. This is a acm, acceleration of the center of mass. Here velocity of the center of mass and position of the center of mass xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Similarly, vcm and acm. Here one more thing we can write here, pcm momentum of the center of mass is equal to p1 plus p2 plus p3 so on, like that we can take. F here also we can take respective value, f net is equal to f1 plus f2 plus f3 so on. As you are taking the net force acting on the system is equal to individual for sum of the individual forces, it will come like m acm is equal to m1 a1 plus m2 a2 and so on. Two dimensionally center of mass, position vector of center of mass, let us see. Here there is a particle of mass m1 whose position vector is r1, other mass m2 whose position vector is r2. It is x1 y1, this is x2 y2 coordinates, x axis and y axis. Then we can write as r1 is equal to x1i plus y1j, r1 position vector of the first particle. Next, position vector of the second particle can be taken as x2i plus y2j. Next, RCM can be taken as m1 r1 plus m2 r2 by m1 plus m2. It will be taken as RCM. Now, R1, R2 individually we know by substituting we will get the respective center of mass of the resultant one, that is the RCM will be obtained. Center of mass of, this is the center of mass of these two bodies. From there we can obtain RCM is equal to m1 r1 plus m2 r2 by m1 plus m2. It is a position vector of the center of mass of the two-dimension motion, two-dimension system. Now let us see the numericals based on the expression for the center of mass. So different models. Two bodies are separated by a distance d. Those two bodies of masses m1 and m2 separated by a distance is, those two are separated by a distance d. How to find out the center? Find the center of mass with reference to the m1. The question will be with reference to the m1 they will ask. So which one they are asking, that should be taken on the origin, rest of the body will be taken at such distance. It is m2, it is m1, this is d distance means you take d comma 0 have to take, it is 0 comma 0. It is x axis, this is the y axis. XCM is equal to m1 x1 plus m2 x2 by m1 plus m2. Here XCM is equal to m1 x1 is 0 plus m2 is m2, x2 is d by here x1 y1 x2 y2. x2 is d, y2 is 0. So here m1 plus m2. Now XCM is equal to m2 into d by m1 plus m2. The expression for center of mass from the first body. Center of mass is somewhere else, here first body. Like example you take as there is a two masses of 2 kg and 5 kg separated by a distance of 10 centimeters, position of center of mass. Then what you have to find out? XCM is equal to m1 x1 plus m2 x2 by m1 plus m2. Here XCM is equal to m1 is 2 into 0 because 0 comma 0 here, and next one is here coordinate is, if it is given as 10 centimeters means 10 comma 0. Then m2 is 5 into 10 by 2 plus 5, this is 50 by 7. XCM is center of mass is 50 by 7 centimeters from the 2 kg body. From the 5 kg body means what? Total 10 minus from the 5 kg body 10 centimeters minus the center of mass is here to here is XCM we got. So total distance minus this distance gives this. This is nothing but what? XCM 10 minus XCM. 10 minus XCM gives the, that is d dash here, whatever the distance in between them. Three bodies in system. Next example. One kg, 2 kg, 3 kg. 1 kg, 2 kg, 3 kg. It is a two-dimension x-axis and y-axis. In plane, the three masses are located. In the vertices of triangle of side 1 meter, then the center of mass of the system, that is the question. Of side is 1 meter, means equilateral triangle. Then find the center of mass, that is the question. We have to take as 0 comma 0, here 1 comma 0, the coordinate here. What is this coordinate? That coordinate is nothing but, here we have to take, it is 1 by 2 from here to here. Obviously x coordinate is 1 by 2. This is a y coordinate, To find out the y coordinate is also 1 by 2, 1 by 2, x coordinate is 1 by 2. Y coordinate is, this is a y, distance is y coordinate. From the x axis how much distance is there to the point, that is y coordinate. To find out the y coordinate, it is y, it is 1, it is 1 by 2. So y is equal to here under root of 1 square minus 1 by 2 whole square. I mean to say Pythagoras theorem, 1 square is equal to y square plus 1 by 2 square. Y square is equal to 1 square, y square plus 1 square is equal to 1 by 2 whole square is equal to 1 square. Here we want y, 1 minus 1 by 2 whole square, that is under root. Y is equal to 1 minus 1 by 4, y equal to root 3 by 2. Now XCM and YCM both will be here. XCM is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. m1 is 1 into 0 plus m2 is 2 into 1 plus m3 is 3 into 1 by 2 whole by 1 plus 2 plus 3, that is equal to 2 plus 3 by 2 by 6, that is 4 plus 3 by 12, that is 7 by 12 centimeter XCM. Here the value of XCM is 7 by 12 centimeters, and the YCM, similarly YCM can be taken as, YCM is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Here YCM as 0 plus, because m1 y1 is 0, m2 y2 also 0, m2 is 2, y2 is 0, it is x1 y1, x2 y2, x3 y3. Respective value is, it is m3 is 3, y3 is root 3 by 2 whole by 1 plus 2 plus 3, as masses are 1, 2, 3. So now coming to the point, YCM is equal to 3 root 3 by 2 by 6, that YCM is equal to 3 by 12 into root 3, 3 ones, 3 threes, root 3 by 3. Here 3 root 3 by 2, 3 into root 3 by 2 by 6, 6 2 is 12, so 3 by 12, 3 ones, 3 fours, so therefore it is root 3 by 4 is CM. XCM, finally the position of the center of mass of the coordinate system is, XCM is 7 by 12, YCM is root 3 by 4 is the position of the center of mass. Next let us see, these are 3 particles individual are taken and 3 masses are taken, like 1 kg, 2 kg, 3 kg in the at 0, 0, 1, 0 and 3, 0, but the coordinates we are supposed to write like 0, 0, 1, 0, because, and third coordinate is as 1 by 2 from the x-axis, distance from the y-axis is 1 by 2, that is there is 1 by 2, distance from the x-axis y is, that is root 3 by 2. By taking the coordinates we can substitute in expression XCM and at the same time YCM. XCM we got as 7 by 12 and YCM is root 3 by 4. Next let us see another model. It is very important, 3-dimensionally how to do the problem. Let us see. The problem is here 1 kg, the question 1 kg, 2 kg, 3 kg. 3 masses are taken, the center of mass is given as 2, 2, 2. Again I am repeating. 1 kg, 2 kg, 3 kg, 3 masses are, their center of mass are 2, 2, 2, XCM, YCM and ZCM. These 3 cages are located in space, means in with reference to the x-axis, y-axis, z-axis, in that space it is located as XCM, YCM, ZCM as 2, 2, 2. Fine. Now Third, one more 4 kg mass is entered into the system. 1 kg, 2 kg, 3 kg and 4 kg. Then that time center of mass is shifted to 0, 0, 0 is given content in the problem. Then find the position of the 4 kg mass. X4, Y4 and Z4 is how much? That is the question. It is very important in the competitive exam point of view. Logic is there in that. By using the logic, we have to solve the numerical. That is, the given problem is like 1 kg, 2 kg, 3 kg mass is given. The center of mass is also given 2, 2, and 4 kg mass is taken into the system, that is shifted to 0, 0, 0. Then where is the 4 kg mass? For this numerical, I will give an example. Assume that in your classroom, there are the 3 students. 3 of them, మీ ముగ్గురు ఒక దగ్గర కూర్చొని మాట్లాడుతున్నారు. Those are 3 members కి center of mass ఉంటుంది. Right. That center of mass, again one more person, one of your friend again, 4th person is entered, the center of mass will be shifts, obviously. Because the mass is increasing, the center of mass is depend upon the position and distribution of masses. As distribution of mass is changing, right? The 4th mass is entered, center of mass are supposed to shift. That is also given in the problem. That is given shifted to 0, 0, 0. Similar way, here now let us see. First thing is what is given in problem. One hint will be given and one concept will be given in each and every problem. The hint is here. First thing is center of mass of the 3 cases is given, that is XCM is equal to M1x1 plus M2x2 plus M3x3 by M1 plus M2 plus M3. But XCM is given, fine, 2 is equal to, it is M1x1 plus M2x2 plus M3x3 by 1 plus 2 plus 3. 1 plus 2 plus 3 is 6. 6 2s are 12. 12 is equal to M1x1 plus M2x2 plus M3x3. Now by using this, in second case is given as XCM dash. This is XCM dash, YCM dash and ZCM dash. Let us take XCM dash. Is 0 is given. What is the XCM dash? Let us see. M1 x1 plus M2 x2 plus M3 x3 plus M4 x4, because second case 4th mass is entered, by M1 plus M2 plus M3 plus M4 equal to 0, because the center of mass is shifted to 0. So we are supposed to take 0. Then M1 x1 plus M2 x2 plus M3 x3 plus M4 x4 is equal to 0. Obviously 0 into mass are 0, is it no? Then already we know from the first expression M1 plus M2, M1 x1 plus M2 x2 plus M3 x3 as 12, we can substitute in place of the M1 x1 plus M2 x2 plus so on. Then what is the value of that? 12. 12 plus M4. M4 is 4 kg mass. X4 we don't know, we need to find out 0. So 4x4 equal to minus 12, x4 equal to minus 12 by 4, that is equal to minus 3. Similarly, if you go for the YCM and JCM, no need to do again. Similar way we can write as, similarly Y4 is minus 3 and Z4 also minus 3. Therefore, the answer is here minus 3 comma minus 3 comma minus 3 is a position of the 4th particle which is placed in the space, so that the center of mass is shifted to 0 comma 0 comma 0. Shift in center of mass. It is very important for the competitive exams. So first model let us take as shift in center of mass in the case of the disk. Shift in center of mass in the case of the disk when a part of the disk, a circular portion of the disk is removed off. Assume this is a disk x-axis, y-axis, whose radius is r. From here to here, the radius of the disk is r, and small circular portion, disk is small r, is removed off. Small r is removed off. Then, before the disk is removed, you imagine this problem. Take a circular plate and take a circular cross section in the outer edge, just cut it and pick it out. Then situation will be like this, you can find. Obviously, if the mass is removed off, center of mass supposed to be shifts back. How much back it is shifting, we need to find out. Again, I am repeating. Before removal of the mass, the center of mass was here, at the center of the disk. As the masses get removed, the center of mass will be shifts back. Okay, how much it is shifts back, that is x2 assume. From where you are removing, that is x1 assume. Okay, we need to find out the x2. That let us see. I will take the portion which is removed is m1, the remaining mass is m2. Here x1, this is x2. The condition is m1 x1 should be equal to m2 x2. About the center mass, m1 is what? Removed mass. The easy method, already m1 r1 is equal to m2 r2 about the center mass. Similarly, we can take m1 x1 is what? X1 is capital R minus small r is x1. Total is r, this is small r, this is obviously capital R minus small r. So, capital R minus small r. M2 is remaining mass. Remaining mass is capital M minus small m. M2 is, M1 is M. M1 assume that M. M mass is removed, remaining mass is capital M minus small m. Here capital M is total mass of the disk. Small m is mass of removed disk portion. Now, here x2 we need to find out. Simply I am substituting in the place of m, small m. X1 is position of the removed mass and m2 is a remaining mass, that is capital M minus small m into x2. Here we want x2. x2 is equal to small m by capital M minus small m into r minus small r. So, this we can remember for shortcut, removed mass into its position is equal to remaining mass into its position. That is the concept for the problems. Removed mass is m, its position is capital R minus small r, is equal to remaining mass is capital M minus small m, that is m2 into x2. Now, x2 is equal to m is here, because disk is a, what is it, 2 dimension, that is surface density it possesses. This is uniform disk we are taking here. So, disk sigma is equal to mass per unit area, mass equal to sigma into A. So, small m is equal to sigma into A. Sigma A is pi small r square. Similarly, capital M is equal to sigma into, it is A1, A2. A2 is capital A, that is sigma into pi into capital R square. Area of the disk is sigma into pi r. Area is pi r square. The mass is sigma into pi r square. So, we will substitute the values of small m and capital M. Small m is sigma into pi small r square into capital R minus small r by sigma into pi capital R square minus sigma into pi small r square, right. So, by taking common, x2 equal to sigma pi r square into capital R minus small r down, denominator sigma into pi common, capital R square minus small r square. Then sigma pi get cancelled. The final expression is x2 is equal to r square into capital R minus small r by r plus r into r minus r. Since it is a square minus b square formula, a plus b into a minus b. So, these two will be get cancelled off. Then x2 is equal to r square by capital R plus small r. It is an expression for shift in center of mass in the case of a circular disk portion is removed from the big disk. Right. Now let's take an example based on this one. Example. A disk of radius r by 2 is removed from a disk of radius r is equal to r. Then shift in center of mass is how much? That is the question. So this is a very important formula. Instead of deriving the entire thing, the shortcut you can remember that x2 is equal to r square by capital R plus small r. Either the equation solving method or direct formula base. Now let us see how to see the numerical instead of doing entire thing. A disk of radius small r is r by 2, means the diagram we can draw like this. Here from here to here is capital R. The question is even small r. Small r is capital R by 2 is smaller. Now how much shift in center of mass will be takes place from the center? That is x2. Let us take. Just now we got an expression for the shortcut x2 is equal to r square by capital R plus small r. Fine. So x2 is equal to r square means r by 2 whole square whole by r plus r by 2. Then r square by 4 by 2r plus r by 2. That is r square by 4 into 2 by 3r. Here r square r get cancelled. 2 1s, 2 2s. Then it will be r by 2 3 is 6. R by 6 is the answer. Or else we can use the removed mass into its position is equal to remaining mass into its position also. We can use the model. So this is a numerical based on the shift in center of mass in the case of the disk portion. In case of sphere, same process, but the formula is very simple. Removed mass m1 x1 is equal to m2 x2. Is spherical portion is removed off. As spherical portion is removed off, obviously this part is removed off. Center of mass of removed one is m. Remaining mass is capital M minus small m. I mean to say it is m1 is m. m2 is equal to capital M minus small m. The distance is here to here is capital R minus small r. It is x2. This is x1. Now m1 is removed mass. x1 is the position capital R minus small r. m2 is anyway that is capital M minus small m into x2. Here we need to x2. Same way easily we can identify rho is equal to density is equal to mass by volume, mass equal to volume into density. So mass volume is 4 by 3 pi r cube. Similarly capital M is equal to 4 by 3 pi capital R cube into rho. Same from the same disk only we are removing the part. That is the reason density will be same. Because m is a small m is a removed portion, capital M minus small m is a remaining portion. Those two masses are from the same disk. That is the reason the density is remained same. But which is differing? 4 by 3 is same, pi is same. Only the small r cube it is capital R cube. That means mass is depend upon the radius. So let us substitute instead of writing all those things, we can straight away we can substitute, because this is a constant, this is a constant. Anyway constant will be removed off. We can write r cube into capital R minus small r. In place of m, we can write constant into r cube. In case of constant into capital R cube, where constant k is equal to 4 by 3 pi. Here 4 by 3 pi into rho. 4 by 3 pi, 4 by 3 pi is a constant k. We can write k r cube equal to here k into capital R cube minus small r cube into x2. Now k will be get cancelled. R cube into capital R minus small r minus small r into r square plus small r capital R plus small r square into x2. It is very simple. A cube minus b cube formula. A cube minus b cube is nothing but r minus r into a minus b into a square plus ab plus b square, that is the formula. Just these two will be get cancelled. The final answer is r cube by r square plus small r capital R plus small r square. It is very important formula for the competitive exams, that is to find out the shift in center of mass in the case of the spherical portion of the mass is removed from the sphere of radius r, and small r is the radius of the removed one. Shift in center of mass of square plate. In a square plate, a part is removed of center of mass will be shifts. Assume that this portion is removed of. Shift in center of mass plate. When a square plate is removed from the a big plate of side 2a, the shift in center of mass will be, obviously it will be back. The shift, let us take as x2, it is x1. We need to find out the x2 is equal to how much, the question. Let us take the same formula, m1 x1 is equal to m2 x2. m1 is a removed mass, x1 is the position of the removed mass, m2 is a remaining mass, x2 is a shift in center of mass. Right. Let us take m1, how much mass we are removing? The mass is m by 4 mass is removing. x1, how much remaining mass is there? 3 by 4 of m, 75% mass is remains. Here m get cancelled, x1 by here 4 also 4 get cancelled, x1 is equal to 3 times of x2. What is x1 here? x1 is the 2a, this is also 2a square plate, this portion is a and a. The total is under root of a square plus a square, that is root 2 into a. So half of the portion is x1 is equal to root 2a by 2, x1 is equal to a by root 2. So we have supposed to substitute in place of x1, a by root 2 is equal to 3 into x2. x2 is equal to a by 3 root 2. It is a very important concept. The other way, it is a shortcut method. If you go m1 x1 plus m2 x2 by m1 plus m2, that method it will be long. It is removed mass into its position is equal to remaining mass into its position is the easy method to find out the answer in the very short span of time. So let us see the other model. Here this model again I am repeating, m1 x1 is equal to m2 x2. m1 I am removed mass is 1 by 4th of the total mass, assuming that as the total mass is m by 4th mass is removed off, and remaining mass is 3 by 4th of the mass is remaining, and x2 is a shift in center of mass, it will be back, not exactly center. So x1 is equal to 3 times of x2 we got. As finding the x1 from the diagram, so a by root 2, substituting over there x2 is equal to a by 3 root 2. Shift in center of mass, another model. There is an ice cube which is in a tray. Ice cube in a tray, assume. This ice cube is, center of mass of the ice cube is, as side is L, ice cube is at L by 2 distance. Center of mass of the ice cube is at L by 2 distance from the, we want to find out the shift in center of mass of the ice cube when it get melted. After melting, what is the shift in center of mass? So let us see. Same formula, m1 x1 is equal to m2 x2, but m1 is mass of the ice cube. x1 is where it was at L by 2 distance. m2 after melting capital M and small m together, center of mass will become to the one point, that is capital M plus small m into x2. So now x2 is equal to m into L by capital M plus small m into 2. That is finally x2 is equal to m by capital M plus small m into L by 2. Shift in center of mass from the previous position of the system, that is x2 is equal to m into capital M small m by L by 2, or x2 is equal to ml by 2 into capital M plus small m. Now let us see another model. Shift in center of mass and position of the person in a boat from the shore. It is very important model, boat. So boat and person position with reference to the shore. When the person moves, assume that it is a boat. Surface of the boat, assume a person is standing on the boat. The mass of the boat is capital M. It is water. It is shore. From the shore, the distance of the boat is d. Mass of the man is m. Mass of the man is m. Mass of the boat is capital M. Distance from the shore is, boat is at d distance. Now, when the person is moving towards the shore, the length of the boat is, let us take L. L is the length of the boat. Total length of the boat is L. As from person is moving from one end to another end of the boat towards the shore, then what might be the, obviously as a person is moving, the momentum will be back, the boat will be moved back. To what distance it can move, we want to find out. That is x2. The principle is m1 x1 plus is equal to m2 x2. Clockwise moment is equal to anti-clockwise moment. So m1 is mass of the man, x1 is length of the boat, m2 is mass of the man plus mass of the boat into x2. x2 is equal to ml by capital M plus small m. This x2 is the distance moved by the boat. Now what we want, as the distance is moved by the boat is x2, the person is moving forward, the final distance of the boat will be d dash, let us assume. D dash is nothing but d plus x2, that is nothing but d dash is equal to d plus ml by capital M plus small m. The final position of the boat will be at d dash is equal to d plus, before that it was at d, and x distance, x2 distance it is moved, so that it is ml by capital M plus small m. This is the final position of the boat from the shore. The first case, and the second case is, let us see, the person is moving away from the boat, away from the shore. Let us see. Assume this is shore, it is a boat. Here person is moving from here to here. The length of the boat is L, same way. It is at a d distance from the shore. Then that time the x2, same way, m1 x1 is equal to m2 x2. Here m is mass, x1 is length of the boat he can move, and m2 is capital M plus small m into x2. x2 is equal to ml by capital M plus small m. But final distance is, as the person is moving in this direction, the boat will be moved back, x2 will be in this direction. Though final distance is, it is x2, remaining distance is d dash. D dash obviously d minus x2. The previous distance is d. Now the distance is moved by the boat along with the man is ml by capital M minus plus small m, that is supposed to be separate. So d dash must be d dash equal to d minus ml by capital M plus small m. The important thing we need to remember here, always in the question they may not give the as the person is moving from one end to other end. Sometimes they may be give from the any part of the boat also. Any part of the boat, that time how much distance he moved, that we have to take as here m1 x1, and m2 is m plus capital M into x2, similar way. But this x2 is not, here x1 is not the total. Assume that, example, let us take a person is moving, x1 is equal to 2 meters. x2 is equal to how much? Where is the position of the boat and position of the person also? So if before that initially was at edge, now x2 is equal to, here ml by capital M plus small m. X2 is equal to m is mass of the person, m is moving. L place we have to take as a 2 centimeters because x place I am taking as a 2 centimeters. So into 2 by capital M plus small m. Rest of the problem is as it is 2m by capital M plus small m. So x2 is the distance moved by the person. Boat is moving back. So rest of the distance, now the final distance can be taken as d dash is equal to d minus 2m by capital M plus small m. Assume that is a 10 meters is given, the 10 meters are supposed to substitute and m and capital M small m values are supposed to substitute. Again I am repeating, x1 is at 2 meters, the person is moving 2 meters away from the shore, 2 meters, x2 is equal to, here x1 is equal to 2 meters. If he is moving 2 meters, before the problem it was L distance is moving straight away from one end to another end. Now at this position, just it is moving only 2 meters. So in place of x1, 2 meters only we have to take. x2, how much distance is the boat is moved? That is x2 we need to find out. The same way we have to find out the x2. Here, after finding that one, instead of taking the L, we will take whatever the value we got, that we are supposed to substitute over here. We will get the final distance. Shore to the boat, but at the same time, about the person, how much distance he is away. So actually as the boat is moving away to meet this much d dash distance, here x2 distance the boat is moving away. Now the final position of the person is d double dash I will write. D double dash is equal to, d dash is the boat. So here d dash is equal to d minus 2m by m plus small m. Here d dash is the final distance, final position of the boat along with the man from the shore. So d dash is equal to d minus x2 because x2 distance is the boat is moved front. That is the reason final distance is, before that it was at d, now it is moved x distance, x2 distance. So final distance might be, I mean to say the boat as it is coming like this, like this. So now the position is d dash only. This distance we want. So total distance minus this gives this distance. So d dash is equal to d minus 2m by capital M plus small m. Now here d double dash is equal to d minus, now the position of the person. It is the position of the boat we did. Now position of the person. Position of the d double dash is d minus x2 as it is, plus that fellow is moved away from 2 meters from the shore. So that we need to add. Then the final position of the person along with the boat, how much he moved, that we have to subtract. But how much he is moving away, that we have to add. So final distance is d double dash is equal to d minus x2 is anyway 2m by capital M plus small m plus 2 is the final distance. Center of mass of the regular shaped bodies, like if the center of mass of one circle and one square, find the position of the center of mass of those two are made up of the circular plate and square plate. Both are made up of the same material. So let us take, this is a origin, like we can take from the circular plate reference we are taking, that is m1 and the rest of the mass is m2. Square plate mass is, let us take m2. The position is here 0, 0. This is r. Assume the side is a. This is r plus a. Side is r plus a by 2. Total is a. From here to here is a by 2. Half of the distance of the plate is a by 2. A by 2 plus r. So r plus a by 2. Now position of center of mass xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. So xcm is equal to m1. M1 is mass of the circular plate. Mass of the circular plate what might be? M1 x1 is 0 plus m2 x2 by m1 plus m2. Here xcm is equal to m2 x2 by m1 plus m2. m1 is equal to sigma into a, area of the plate, area of the circular plate. Area of the circular plate is m1 is equal to sigma into pi small r square, m2 is equal to sigma into pi sigma into a square. Area of the square plate is side into side square, a into a square. So now let us substitute xcm is equal to m1 is sigma into a square sigma into a square into x2 is the distance is r plus a by 2 whole by m1 is sigma into pi r square plus sigma into a square. So xcm is equal to sigma pi will be get cancelled, sigma will be get cancelled here, a square into r plus a by 2 whole by pi, sigma will be cancelled here as you are taking the common, so pi r square plus a square. The final expression for the shift is center of mass of the two system here, a square plus, as I am taking common, sigma is a common for both of them, same material, so a square into r plus a by 2. So finally we can write as xcm is equal to a square plus r plus a by 2. The respective values are given, substituting we will get the perfect value of the content. If the numerical variable is given, you are supposed to substitute the particular values over here.